All right, exercise 5A. You are practicing what we call set notations and set of numbers. And what you're really doing is you're learning the language of mathematics. Often when we're doing mathematics, we define certain things, we look at certain numbers, and you don't want to be writing in words. It takes too long to do. So what we do is we use symbols to illustrate that. What you're learning in 5A is those symbols, some of which you've already seen. For example, the very top here, what's that one called again? Hands up. Oh no, I'm going to pick on you then. Let's go, Ben. It is the intersection. Write it down. It is called the intersection. But in layman terms, or in how we speak in English, what is intersection? What does this symbol mean? What do we use it for? The intersection means what? Massey. Yeah, it's what they both share in two groups. Okay, because we talk about numbers. Numbers can come in a group, and in two groups, what do they both share together, or what do they have in common? So if it helps you, just thinking, what's in common or shared? What's shared between the two groups? Whereas the upside down shape, so this is called the intersection. This one is called what? Let's go with Jason. Union. And union is in some ways easy for us to remember. Union is like uniting. So uniting, what are you going to do with the two groups? You are putting together. Very good. So really you're just including, just think of include, unite, or put together both groups. Okay, so you've got two groups of numbers. You're going to combine them. It's kind of like our class and Mr. Hiller's class. If we went over to that class right now, that's uniting. That's a union of 11 methods, and I don't know what he's teaching. It's probably year 9, year 10 maths maybe. And then these symbols you may or may not know. So the first two you would have seen in probability from year 8, maybe year 9. Usually probability is like the lost brother of the topics. We usually do it last, and sometimes we don't have enough time to go through them. Welcome. Do we have a spare? Yes, we do. I don't know if this cord is long enough. It might not be. All right. Next one. This symbol is called a subset. Subset means it belongs entirely to another group. Belongs entirely. So what's an example? I'll draw a picture, it makes it easy to see. So if this is group A, okay, then group B, if it's totally within A, that's called a subset. It's within it. So if you think of numbers, I could say A is the numbers 1 to 10, and B is the number 3. Okay, so if A was all the numbers from 1 to 10, and B was just the number 3, or 3 and 5, it's a subset of A. It's a part of it. Okay. Backslash used to be a really big key thing that you have to do in backslash. I used to tell my year 11s that if you don't do backslash and you do a forward slash, I will give you a backslap because then I will take off marks. Nowadays, they don't take marks. It used to, that if you do it wrong, everything's wrong. I think the examiners now can be a bit generous on that, but still, I'd still say the same. Backslash or backslap, okay? Backslash means to exclude. So you want to exclude certain numbers. Backslap you. Exclude the numbers, okay? And then lastly, a null set. This is a null set. Okay, so a null set is different to 0. How is it different? 0 is a number. 0 means if I said this group has 0, I'm not saying it doesn't have any numbers in it. I'm actually saying it does have a number. The number is 0. Okay, whereas null set actually means there's literally nothing in there. So often you can use that symbol there, or you could also use an empty braces brackets. Okay, and that essentially means I've got nothing in here because I don't see anything there. Okay, null set, I'm going to write here in blue, not the same as 0. And some common notations that we normally use in methods that you might have seen already are, hands up if you've seen R, or at least I've explained or you've heard of R before. Okay. R stands for all real numbers, and it just basically, when they say real numbers, they just mean numbers that you can currently compute with, or you can write as a fraction, or not a fraction, like irrational numbers. Yeah? Irrational, I'll explain that soon. The reason why they call it real is because someone has already created, and that was back in the days where algebra came back, they figured out there was a problem. What can't you square root again? Negative numbers. So they said, there's a problem. I can square root 1, but I can't square root -1, and they came up with a concept to make that work. And then they called that imaginary. So it's complex numbers. If you do specialists, they will teach you a new set of tools, kind of like when you first learnt 3 take away 1, you know how to do, 3 take away 2, you know how to do, 3 take away 3, you know how to do, and then when you get to year 7, 3 take away 4 might have been new, because that breaks the rule. Okay, we always worked with whole numbers, and then so they had to come up with negative numbers to solve that problem. So because they came up with a negative number line, you then had to work out negative number rules, like double negatives is positive, positive negative is negative. Those rules came about. Same thing here. That became a problem. So then what do? They come up with a system to make that work. And that's called complex numbers and imaginary. So for your sake, in methods, we generally only stick with real numbers. We don't have imaginary numbers. But if you do special, you'll then learn, well, how do you combat the problem of -1, root -1? Okay? Now, within real numbers, if real numbers R is the set of any number that you can think of, no matter what number you think of, all the numbers that you've been working in your whole sort of experience so far, that's R. Within R, there are numbers that you would have learnt along the way. This is how I like to explain it. N is what you learnt in primary school. N stands for natural numbers. What's a natural number? 1, 2, 3, 4, 5, so on. Those are called counting numbers. Okay, so that's pretty much what the ancient civilization started off with mathematics. Why do we use maths, or how is maths useful in life? It started off with, well, I need to count. I need to keep a budget of the economy. Bookkeeping and counting was one of the first mathematical concepts that came about. So natural numbers. Then after you learned natural numbers, you got positive, you can then work in. Now Z is the next one. So Z is what you start in year 7. So primary school, you were happy with counting to 10, to 100, to 1,000, add, subtract, multiply, divide. That's pretty much what the most basic civilizations would have followed. And then negative numbers. Negative numbers was not possible, and then you had to come up with it. Ancient China figured that out, and they introduced that, and they followed on, right? So negative numbers come in, and that's what you did in year 7. You started off year 7 expanding your repertoire of numbers, and you went to what we call integers. Integers just basically means whole numbers, but not just positive. It's positive or negative. Okay, so that's why natural numbers is just the positive numbers, and then integers is whole numbers as well, but you have plus or minus. You probably grab a sheet just up there. And then finally, so this is year 7. That's year 7. That's primary school. And then Q is where I think a lot of students gave up. And students still suck at. And that's what the examiners test. Q stands for, rational. Irrational numbers. What am I talking about? Is it irrational or rational? Rational. Sorry, my bad. Rational. And what are rational numbers? Numbers that are not whole numbers, but in between. So what's in between? You got decimals, fractions. Okay, so 1/3, There's 0.33333, 0.5. Okay, those are rational numbers. And by definition, this might confuse you, but rational numbers means that, well, by definition, it is a ratio of integers. And what it basically means is you can write it as a fraction of two numbers that is a whole number. Okay, that's by definition what a rational number is. Funny enough, a fun fact that I recently learnt as well. Back in Pythagoras' time, they believed that the universe can only be up to rational numbers, but it cannot have numbers that were infinite. For example, root 2. Someone suggested that root 2 might exist, and that really pissed off the Pythagoreans. They were a group of people, it's kind of like a cult then, and so they actually killed that person. They submerged him in the beach. Later on, we do realize that, yes, there actually is a possibility of irrational numbers, and it sits in this bracket here. So we've got positive whole numbers here, negative numbers, whole numbers here, and then to branch it out, well, you got in between it, so that's fractions here, so you can think of like half, a third, even repeated decimals is still, you can write it as a fraction. So all the fractions can be written here, but then every other number that you can't write, for example, pi, Euler's number, E, which is a very special number, and surds. This is the bracket that you started to learn in year 9. Okay, fractions you learned in primary school, but this bracket here is what students tend to struggle with. And that's the bracket of irrational numbers. Everything that's outside of fractions, everything that's outside of negative numbers, and then positive numbers. Okay? And in methods, we do work quite a bit with surds, fractions, and pies later on. Cool? So that's just a bit of a number knowledge. In your case, if you didn't understand everything I just said, most likely you're only going to work with R and Z. I don't think your textbooks or your examiners will use many more than that. Just R and Z is often common. Okay? If you're in Spec, you'll probably use the whole range. You might even use I or complex numbers as well. All right, let's move down now. So this is the actual part that you'll do the exercise for 5A. 5A wants you to convert what you're used to doing so far with your less than, greater than symbols in interval notation. Okay, so you were used to doing something like this. A number that's between -3 and 4, even though from exercise 3G I can see some people still need to practice that skill there. But -3 to 4 on a number line represents -3 to 4, and it says x is bigger than -3, but not including, and it is less than 4 and not including. So it must be somewhere there. So x is any number that's between these 2 points, but not -3 and not 4. That's what that represents. Okay? We're moving away from the standard notation to getting you writing in interval notation. There are only 2 types of brackets that you'll be using. When you want to say inclusive, you use a square bracket like the one shown. When you want to say not inclusive, then you would do open bracket. Okay, so we're going to write an open bracket. Smallest number is always on the left, largest number is always on the right. That's by convention. Okay, so by convention, smallest number should be from -3 all the way to the largest number I have to the right is 4, but not including. So that's what the open bracket means. If you have a look at my next interval notation, what's that saying? Including. So it says, I want 1. Smallest number is 1. So I'm saying x, smallest number is 1. It's including. So x must be bigger than that. But then there's also an upper limit. It's saying that 10 is my largest value, and you include 10. So it must then look like this. If you're wondering what the squiggly brackets and the x means, we only use this squiggly bracket, or called braces. That's the technical name for it. We use that when you're listing. So we're listing numbers right here. Okay, so we use it for listing. So I'm listing a set of numbers, and what numbers am I listing? I'm not listing coordinates. I'm listing just the x values. So what that's normally saying, the technical name for all the x values is domain. That's for the next exercise, 5B. Domain represents all the X possible numbers that you can work with, and then range is all the Y values you can work with. All right? So here, if you wanted to, you could do, if you know this is just the X values, then you would then say X colon. You're saying, I'm listing all the numbers that is to do with the X axis, and the numbers are 1 to 10, inclusive of 1 and 10. Let's try the next one. What about if I want to say -1, X is greater than -1, but less than or equal to 2? What should the interval notation be? Can I please have, let's go with Zoe. Have a go with this one. What would the interval notation be? Curved bracket, so open bracket. -1. Perfect. That just basically means going from -1 to 2, don't include -1, but include 2. What happens if you want to say something like that? What does this mean now? So number line, 4 is over here, and it looks like it's including 4, so I'm using a nice full circle, including 4, and it's and the smallest number is -infinity. How do I say that in standard notation? So back then in year 7, you would have got a picture like this, and they said, how do you describe that with the inequality sign? What would you say? Luke? Sure. Start with X. What is X? So based on this picture, what can X be? X could be 4, I can see that. What else can X be? X is less than 4. Now, how would you say X is less than 4? I've got an X there. Less than 4, which symbol am I using? Yeah. Like that. 4. But that's still wrong. What am I missing? Beautiful. So that's what you did in year 7. So year 7, you were looking at number lines. You had to learn how to read this, and that was just saying X is a number. So I can pick any number. It could have been 3, could have been 2, could have been 1.1. All that line there represents is all the possible numbers X can be. This is the same thing. This is just saying -infinity all the way up to 4. Any number in between that, that's the number you want. Okay? So that's what you'll be doing in exercise 5A so far. Can you see how they got these notations that you're learning to use? Interval notation is what you're practicing. Hopefully it practices your standard notation if you weren't good with that, especially from 3G, that I noticed from 3G, your notations were all over the place. Make sure that smallest number is always on the left, largest number on the right. Never switch it. Okay? Let's do some examples. Here we go. Let's see if you understand this now. Let's read the notation. So I said A is the group, or the set, group of numbers. I've got 2, 3, 5, 7, 9, 11. B is the group of numbers that are 7, 9, 15, 19, 23. When I say part A intersection B, you told me it's what's in common. So when I say A intersection B, what is in common in group A and group B that you can see right now? Let's go Numafi. What do you see that's in common between group A and group B? They have a 7. Yes. They have a 9. That's true. Is that it? That's true. It's only 7 and 9. So how do you write your answer? Use your braces, squiggly brackets, because you're listing. You're saying, I've got a 7 and I've got a 9. That's a proper notation. So group A intersects with group B. What do they both have in common? They both have a 7 and 9. Let's try the next one. B. A union C. Union means to unite, to group them together. So if I took group A and group B and I put them together, then what should my answer be? Can I please have, let's go with Lucky. Group A, that's group A and C, my bad. If I grouped A and C, so A's here and C's there, what would I get? Yep. Yeah.
2, 3, 5, 7, 9, 11, 15, 19.
Beautiful. One of the things that you noticed that Lucky did was he did not repeat the 2's. Okay, so they both had a 2. It means that if you think it in reality sense, that you could be finding the same person in 2 subjects. You don't count them twice, they're still the one person. There's only 1, 2. Okay, so you don't repeat it. So when you unite them, you only unite individual elements. In this case, they have both a 2, and what do they both have? They both have a 7. They both have a 9. You didn't have to repeat that. You only write the numbers that are different. Cool? Backslash. Remember backslap. If you do forward slash, I will kind of remind you. I normally would penalize, but I'll just remind you it's not backslash. It's not forward slash, it's backslash. What does A backslash C mean? What do you think that means, Mete? Very good. To exclude C. That means accept or exclude. So I'm not going to accept anything that is C. Well, we already highlighted what was in C. C has 2, 7, 9. They have 2, 7, 9. So I want to write A, well, without C. So 3, 5, 11 is all I have. That is A, that is excluded C. Okay, because I don't want C. Backslash, not forward slash, backslash, or a backslap. D. What does this mean? Read the symbol. You got 7 to 12, and the brackets are there, but intersect B. What are they trying to say? What are they trying to say here? Let's go with Christina. What do you think they're trying to say? Did you say union? Intersection. All right, intersection of B. So what is in common between 7 to 12 and 7, or anything in B? So what's in common? We can see that they both have a 7, but be careful there. They both have a 7. 7 to 12, they both have a 9, and that's about it. But why did I say be careful? What's the answer? Yeah, so this one, even though you can see a 7, it said don't include 7. Here, I truly have a 7. So what's in common about the 2? This was pretty much starting from anything but 7. So 7.1 it would be included, but not 7. Here, I have a 7. So when I say what's in common between the 2, it's only a 9. The answer is 9. If you wrote 7, it would be wrong because I never had a 7 in this group. Okay, so in this group of numbers, it was between 7 all the way up to 12, inclusive of 12. Okay, so be careful with the notation. That's an example of 5A so far. Okay. And the back page, I think you guys can do yourself now. So that is just practicing the number line that we were just talking about. But I think that was the key part, 5A. So the essence of 5A is to do this. So I'm going to give you a bit of a break just so that you can practice some of the notations. So then when we go to range and domain, you can write it properly. Okay. Let's pause the video here and let's give you 17 minutes. 17 minutes. Have a look at exercise 5A. Remember, it's trying to get the essence of 5A. Get the essence of 5A.